Welcome to Year 1, Pure 1, Chapter 12.7, where we're looking at increasing, decreasing functions, continuing the lesson from last lesson about differentiation. But we're no longer looking at straight lines. Okay, we're looking at curves and we're looking at different, some niggly bits about differentiation. So one of them is about an increasing, decreasing function. It is a definition that you have to remember. So we can use the derivative to determine if a function is increasing or decreasing in a given interval. Okay, so a curve could have the different parts of a curve could be increasing or decreasing. So it's not the whole curve that's increasing, decreasing. Okay, we're not talking about straight line because in a straight line, okay, if a straight line, for example, straight line, you can see it's increasing because the gradient is increasing, right? Or decreasing with a straight line if it's a negative gradient. But with a curve, there's more than one part increasing, decreasing. So the function is increasing, okay, if the derivative, so f dash x, the derivative is greater or equal 0. So that means it's a positive gradient. Okay, so the equal 0, the equal part is debatable. Some people put it equal, some people don't. Okay, but it doesn't matter. So it's greater equals to. The function is decreasing if f dash x is less than equal to 0. So yeah, so just remember it for now. Okay, when a function has a positive gradient, okay, it's increasing. When a function has a negative gradient, it's decreasing. So if we look at this part, you can tell this graph is very likely to be a cubic graph. Okay, you can see this part is increasing because the gradient is positive. Okay, now even though, now the gradient in the beginning of the part of the curve, in the beginning of the curve is greater than the gradient in this part, you can see it's less steep, okay, as we approach a turning point. However, the whole part is still increasing because you still have a positive gradient. So we say increasing for x less than equals to 2. It's 2 because you can see a turning point is 2, 3. If we look at the x coordinate, that's 2. Okay, so anything, we look at x value, x less than equals to 2. So one way you could write it is in set notation is, set notation is negative infinity and 2. Okay, now you see a different kind of bracket, okay, which I meant it. It's not a typo, it's not a something gimmick. So a curly bracket, okay, means we're not including the negative infinity. And a square bracket means we're including the 2. That means up to the point 2, so you can see less than equals to, there's a square bracket. Okay, now why do we not include negative infinity? It's more, so this is not really something related to this chapter, but it's more like outside knowledge, I guess. We're not including because the negative infinity is actually not a number, but it's more like a concept. Well, because you can't really put a finger on what number is actually negative infinity, right? You can't put a finger on a number line where the infinity is because there's no such number is infinity. It's just a concept where we know it just goes on forever. So therefore, we cannot put a square bracket on the negative infinity or infinity, positive infinity or negative infinity. We can never put a square bracket on it. Okay, so that's just something small. Yeah, so minus infinity, comma, 2 square bracket. Okay, decreasing. Now for this part, it's decreasing because you can see it's a negative gradient. Okay, so you can see these are negative gradient. Okay, so between 2x equals 2 and 4, they're negative gradients. Therefore, it's decreasing function. So 2, 4. Okay, both square bracket because we're having an equal sign in there. Okay. Oh, actually, we might want to put in here is a positive gradient because we've learned about f dash x. F dash x is essentially derivative. Derivative is about gradient, and this one is a negative gradient. Okay, so right. So for this part, okay, I'll let you. For this part, we would like to try to write as a range. How do you write x greater equals to 4 in similar style? Okay, so it will be a square bracket 4 and then infinity. Okay. So you might see more of these later on in the questions or in year 30 maths, in year 12 maths. You will see it in able. Okay. So get used to this. Whereas this one, you can see x is forever increasing. Okay. So we say x belongs. Okay. I don't know if you've come across this one or have I explained before. Okay, but I will explain this. Okay. This means belongs to. It's a set notation, belongs to. Okay, you actually have seen this in GCSE where in Venn diagram you will see, for example, Venn diagram A belongs to a set of 0, 1, 2, for example. Okay, you've seen this. What about this R? Okay, this letter, this is a Greek letter, okay, Greek letter R means a set of real numbers. So what are real numbers? Real numbers are, in a less formal way to explain this, is anything on a calculator that does not give you a maths error. Okay, so anything that you can put in a calculator that does not give you a maths error will be a real numbers. So, for example, 2 or pi, or if you've learned exponential, square root of 4, square root of 16, square root of 3, 23 over 5, 1.4603035789. These are all real numbers. Okay, what are not real numbers? Not real numbers. Okay, so real numbers. Okay, so versus when they're not real, we call them complex numbers. Now, that's not required to know for normal maths. If you're doing further maths, area for further maths, that's the very first chapter you learn. But complex number essentially is like maybe when you square root negative number. So when you square root -1, the calculator gives you math error. That's a complex number. So that's not a real number. Okay. So anyway, for normal math student, you don't have to know any of these, but you have to know the symbol. Okay. You will get used to use this as well. Okay. So when they say it's always increasing, okay, so we can say here, this always, okay, this always increasing, okay, then we use this function x belongs to a real set of real numbers. Okay, right? So so instead of replacing minus infinity to infinity, so we don't normally use this. Okay, we say x belongs to all set of real numbers. Right. So example, find an interval on which the function f of x equals x cubed plus 3x squared minus 9x is decreasing. So is decreasing means, okay, so you have to recall, okay? If you see a burger, what do? You eat it. If you see a decreasing function, what do? You know f dash x less than or equal 0. That's what we need to do. So we need to do differentiation. So let's differentiate. X cubed, 3x squared, plus differentiate 3x squared, 6x minus 9. Now, by now, I'm not going to explain how to differentiate. So you should have known how to differentiate these simple terms. And we know that's less than or equal 0. So what we can do in here is, okay, if you've got a calculator, the two ways you can do this depends on if calculator have this function. If your calculator have the function where it says inequality, okay, then you can type the whole thing into the calculator, which less than or equal 0, which you will put in the coefficients 3, 6, minus 9. You'll get the answer, okay, -3 straight away, x less than or equals to 1. And that's perfectly valid. In the exam, you can do this. However, if your calculator don't have the inequality function, then you go back to solve it like a quadratic, okay? You go and solve it like a quadratic where you get x equals to -3 or x equals to 1. They can draw a graph, okay? A sketch a quadratic graph. It's a positive quadratic graph, so it's a U shape. The roots are -3, 1. So -3, 1 is like this, -3, 1. We want the part that's less than 0. So less than or equal 0 means below the x-axis. So this part, to represent this part on the graph, is -3 less than or equals x less than or equals to 1. Okay. Now for set notation, okay, just in case, okay, if the question asks you for set notation, this is not required in this question, but you would have seen questions that ask you for set notation in your exam. You will write curly bracket, x colon, okay, that's the standard set notation, curly bracket, x colon, and then put in the answer. -3 less than or equals to x less than or equals to 1, close curly bracket. Okay, that's for the set notation answer. Right, if you're happy with this, practice question 1. Okay, or this time I'll ask you to write set notation. Haha. Pause the video, have a go at the question. Okay, when you are ready for the answer, you can press play. Here are the answers. Okay, for question 1. Increasing function means the f dash x greater equals 0. So we differentiate it and make it greater equal 0. Again, if you calculate, that's show you the answer straight away. Okay. Now, one thing is the calculator. Okay. If you have a calculator, the calculator will show you 5 less than or equal to x. Now, we tend to write x on the left hand side. So you have to manually write this way. Okay. Is this 5 less than or equal to x wrong? No, but it's just weird. Okay. It's like when you're in the UK and some people talk to you, have you seen the tomatoes? You frown upon. What tomatoes? You mean tomatoes? So something similar, okay? you just have to manually change x, put on the left hand side. Okay. So we don't time to do this. But if you don't have it, again, I've shown you the way to do this. And to write set notation, curly bracket, x colon, write one of the answer, x less than equals to 9, close the curly bracket, put a U, okay, for the union, for Venn diagram, and then curly bracket, x colon, x greater equals to 5, and close curly bracket. Okay, right. But if you want to do more about set notation, go back to year 1, chapter 3, okay, about set notations, inequalities. Right. So moving on. Okay, example, show. Now this time is different. Okay, the previous question is find the interval. This one is show that the function is increasing for all real values of x. Remember, this all real value of x is could be replaced by this x belongs to all set of the set of real numbers. Okay, to show. Now, when you want to show something, that means you can't use the answer. So what we want to do is basically we want to show, okay, x cubed, sorry, we want to show the f dash x is greater or equal 0 because increasing. What it means is we cannot use, okay, so cannot use this as working out. Okay, so we cannot use this in our working out. Sorry about my writing, my scribbling. It's not even writing, it's scribbling. Right, so we cannot use this, okay? Unlike the previous, when it's a find, then you can use this, but it's a show, okay? So you can't use this. But nevertheless, what we need to do is, let's do f dash x, okay? Let's do derivative, okay? Derivative is 3x squared plus 6, nope, plus 12x plus 21, okay? To show this, okay, to show this greater equals 0, I'm not sure if you remember this from chapter 7 that you've learned about algebraic manipulations. Proves to show this has to be greater equal 0, we want to use a complete square form. Okay, so I'll write down here. Okay. To show a quadratic has to be greater equal 0, we complete the square. Okay. If you haven't seen this before, I'm going to show you once. Okay, I'm going to show you. You will need to practice it later on anyway. So to show us, so what we'll do is let's complete a square. To complete a square, I'm going to factorize the 3 first. 3, 4x. The 21, I don't need to factorize because in complete square form, I don't need the constant term. Okay, and then 3, complete square for x squared plus 4x, half the value, half the b term, 2 squared minus 2 squared, which is 4, plus 21. Put the 3 back in, so 3 is x plus 2 squared minus 12 plus 21. So 3x plus 2 squared plus 9. Okay, that's the first part done where you complete a square. The second part is where you have to explain it in words. Okay, so because, okay, 3 bracket x plus 2 squared will be greater equal 0. Now this a fact, a mathematical fact. If you have anything squared, okay, the number will be at least 0 or positive. Think about this. If you square any number, the smallest you can ever get is 0. Right? 0, you can get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or anything bigger than 0. Bigger or equal 0. When you multiply the square number by 3, you still have the same result. Okay, if this is 0 times by 3, you still get 0. So this expression has a thing greater equal 0. The value of this must be greater equal 0. Okay, so if this number, if this expression is greater equal 0, then, okay, then 3x plus 2 squared plus 9 surely will be greater than 0. Because if this number already is greater equal 0, if you put plus 9 to it, it's definitely greater than 0. Therefore, okay, the function f of x, so we have shown, okay, so basically we've proven this, so proven, okay, you can see we've proven that because we want to show this is greater equal 0, and we did, okay. Therefore, f of x is increasing when x belongs to self-real numbers. Okay, right. Did I double paste the question? Or is this meant to be the practice, which I know? I think did I make a mistake? Yeah, probably did. I was wondering why it looks so familiar. Just let me double check. Plus 2. Yeah, it's the same question, so I'm going to skip this. Right, practice question 2. Okay, pause video. Have a go at the question. Okay, practice question 2. When you're ready for the answer, You can press play. Here is the answer. It's a lot simpler than you think because there's no b term for this f dash x. So we can skip the complete and square form part, which is nice. So show f dash x greater equals 0. That's what we do. So we differentiate first, get 3x squared plus 15. Now, this, to be honest, this is actually a complete square form already because it's just the bracket thing. If when you say complete square form, x plus a squared plus b, the a value is 0 in this case. That's why you don't see the bracket in here. So because 3x squared is greater equals 0, okay, therefore 3x squared plus 15 definitely is greater than 0, and therefore f of x is increasing when x belongs to a set of real numbers. Okay, right. So next one, again, exam practice. Okay, this time is find. Okay, find. Pause the video, 4 marks. Have a go at the question. When you're ready for the answer, you can press play. Well, here's the answer. Can it be any more straightforward? Any fans of friends in here? So can it be more straightforward? Any more straightforward? I don't think so. Right? So you differentiate it. Increasing function. As long as you remember increasing function is f of x, f dash x greater equals 0. They differentiate, make greater equals 0, put in a calculator. Here your answer. Okay, 4 marks in the backs. 4 marks in the backs. 4 marks in the back. English. So, and that's it. End of lesson. Bye bye.